Things for you to consider when you're going through all this regression analysis, whether you're trying to fit a line or a curve to a bunch of points. And these are just multiple choice questions waiting to happen, right? All right, the first one is this word called extrapolation. This is a big deal for May 10th. You need to know this word. You've got to be able to use it when writing up a certain problem you might have while using a least squared regression model. In the problem that we just did, we were trying to predict the weight of fish based on their length. So we created a graph that, we captured fish that were anywhere from 8.8 grams to 46.6 grams, and you guys fit your best curve on that data. Okay, that's great. We also found that's an outstanding fitting curve. However, we wouldn't want to plug in, let's say, 300 centimeters long to this particular model. Once you get really far outside of the data that created your model, you can't trust it. Let me give you another example. Let's say we were mapping world record 100 meter dash times. I don't know what it is right now. It's about 9 something, right? But if I go back to like the, 1900s, it was about 10 seconds maybe. Okay, and it's steadily gone down, little bit. Probably come up with some sort of a model that gets the world record 100 meter dash times. But I wouldn't say use this model and plug in the year 5000, because if I did, the 100 meter dash time would probably be negative, right? It would be impossible. You guys have done some problems before where you calculated the y-intercept. Wasn't it a nonsensical number? Okay, that's called extrapolation. So if you plug in a number that's really far outside of the domain of the numbers that were given to you, you can't go that far in the future. Okay, it's not really that trustworthy. So if you're asked, can you trust these answers if you plugged in the year 5000 to the 100 meter dash time, you'd say no due to extrapolation. This next one's a big deal too. In fact, we're going to talk more about it tomorrow, and actually the lecture I gave today at lunch, you're going to hear about it here as well. It's called a lurking variable. I've already given you an example about a lurking variable before. Remember the example I gave you? We were comparing the number of cavities children have and their reading level. And we found a very positive association. The more cavities they have, the higher their reading level was. So you're like, wow, I can fit a great line to this. I can predict the future. Be careful now. There is a positive association between cavities and reading level, but are cavities the ultimate cause? Are cavities the reason that the children are reading better? And the answer was no. There was an underlying, we call it a lurking variable. And in this particular problem, the lurking variable is how old they were. It's how old they were that was having the influence both on their cavities and their reading level. You have a couple of problems tonight. And they're going to give you an explanatory variable and a response variable, and they're going to ask you, do you think that that's the cause? You're trying to figure out some logical, maybe lurking variables that might actually be the cause for that as well. Okay, and the last one, when you create a model based on averages. A great example, let's say I'm trying to look at the stock market. And I'm looking at the stock market over time. And I look at all the stocks and I take the average growth or the average decline of all the stocks. And let's say over time, all the stocks together are kind of moving up. Okay? And I can maybe make a model for the stock market. What this guy is saying is, okay, we can make a model on the stock market for all the stocks averages, but would that mean I would then put all of my money into IBM? If the average stock market's going up, should I then put all of my money into one individual stock? No, because individual stocks might have a lot of variability, right? What made this a plus stock market, there's stocks down here, there's stocks up here, right? That was just an overall average of where the stock market was. So if you create a model that's based on averages, okay, predict the future in averages. But don't go predict on some individual entity, Okay, and say that's got to go up, because no, that's not the case. Individually, there might be a great bit of variability. Okay? All right, so your problems with that are based on these three concepts. Okay? Any questions?